Now, graphing systems of linear inequalities isn't a whole lot worse than graphing just regular linear inequalities. You're just doing lots of them, or at least two of them. So system just means more than one. So assuming you're good at graphing regular linear inequalities, let's see how we can do on systems of them. So let me kind of cut to the chase here. So say you've already done some of the pre-work and you've got everything in y-intercept form or slope-intercept form. So I've got these two equations here. And whatever these used to be. You got them all pretty because you're kind of awesome. And here you go. Okay, so now basically what we're going to do is we're going to graph each of them separately and then figure out where they intersect. Okay, so for this problem here, we've got the slope of this particular line is 2. So that's rise over run, so that's 2 over 1. And the y-intercept is equal to 5. So I can pop up here and I'm like 1, 2, 3, 4, 5. And it's right here. And the slope is going to be up 2 over 1, up 2 over 1, like that. Okay, now I'm going to draw my little line. Yeah, like that. I want to check, okay, is this going to be a solid line or a dashed line? If I look right here, I see that that's greater than or equal to, so that's going to be a solid line. So I like my pretty solid line here, except I should really be better at drawing at this stage in my career, but you know, at least I'm good at math, so somebody else can be good at drawing. So the question is, am I going to be shading up from the line or down from the line? I can check that by randomly picking a point over here. I'm not really sure how far to go, but I'm pretty sure if I go out to, say, minus 10, that'll be far enough. Or I could just pick this side, 0, 0. And if that's included or not included, then I know what to do on the other side. So let me just do that. I'm just going to test this one. Okay, so I'm going to test 0, 0. Now for 0, 0, I have is 0, which is y, greater than or equal to 2 times 0, which is now x, plus 5. Is 0 greater than or equal to 5? No. Okay, so that means I'm actually going to be going the opposite direction. So I'm going to be shading this half. See how pretty my shading is. Oh, I'm amazing. Okay. Alright, so that's that guy. So I knew I wasn't including the 0, 0, so I had to include everybody on the upside. Okay, so that's my red equation. My red and yellow. Okay, so now let's try doing it the other part. Let's do this guy. So this one, the slope is negative 1/3, and the y-intercept is 2. So the y-intercept's actually right here. The slope is negative 1/3, so I can say it's minus 1, 3 over. So minus 1, get out. Minus 1, down 1, 1, 2, 3 over. 1, 2, 3 over. And they're connected like that. And now I want to check, is that going to be a solid line or a not solid line? I'm a little careful. So since it is an equality, or not an equality, it's an inequality that has a less than or equal sign, then that means that this is indeed going to be a solid line. Okay? Now, again, I want to check this 0, 0 spot. And if I check 0, 0, I say, okay, 0, which is y, is that less than or equal to 1/3 0 plus 2? So is 0 less than or equal to 0 plus 2? So 0 less than or equal to 2. And it is. So that means that that's the part of that I'm going to highlight or color in. So I'm actually going to color in everything down here. So you see how 0, 0 was a solution of one, but it wasn't a solution of the other. So that's this guy here, he's in blue. So actually, what I'm more interested in is not just the fact that this is this one and this is this one. What I'm actually the most interested in is here, where they intersect each other. So here was the section where they both intersected. And that would be my graphical solution to that system of linear inequalities. So really when you're graphing systems, all you do is you graph one, you graph the other, and you see where they overlap.